Reading Week 4. The main physics idea discussed in this week was that electric field of charge distributions can be calculated by first dividing the charged objects into point charges, and then compute the electric field of each piece, and lastly add the E field of all pieces of the charged objects and use the superposition principle. And one thing that we learned in this chapter is that when we find the E field of a charge that's located on the symmetric plane of an object, the E field is parallel to the direction of the symmetric plane. For example, if a point charge is placed on the symmetric plane of a charged rod, it is going to be pointed away in perpendicular direction from the rod if it's a positively charged rod, and it will point towards the rod if it's a negatively charged point rod. What I already knew from the previous chapter is that E field of a point charge and dipole can be calculated using the equations E field equals 1/4 pi epsilon times q over r squared times the direction vector. And for dipoles, we have one for on-axis and another one for perpendicular. What I did not already know was that E field of a rod in a ring or disc or sphere can be calculated using the method mentioned above, and that we can use integral to find the superposition of every E field of all pieces of the charged object. Something interesting that I learned is that E field inside a spherical shell is equal to 0. And as you can see in the picture, E field inside is equal to 0 because when a point charge is placed wherever that's within the spherical shell, it is going to have charges that are, E field that are applied to the charge in every direction, and then they cancel out, leaving the E field of the point charge inside the spherical shell equal to 0. And field outside is basically calculated using the point charge principle. So how it relates to my major as electrical engineering is that the idea of electric field applies to the theory of electrostatics. And within electrostatics, we're going to learn about capacitance and how energy is associated with electrostatic field. And this basic idea of electric field of charge distributions can be applied onto further topics like this. Lastly, it was confusing to me to picture how the electric field lines of different objects look like. So I searched up on Google and found out the electric field lines of a negatively charged rod on the left side and a positively charged disc in the middle and a negatively charged spherical shell.